Okay. So today 5G.2, it's sort of applications and properties of the scalar product, which means the dot product. We've got a box of properties there, but we'll just get straight into the examples and I'll point them out as they pop up. So firstly, we've got these two vectors and we're told that they're perpendicular. Okay, so this is a property we learned in year 11 with two-dimensional vectors. Same thing applies for three-dimensional vectors. If they're perpendicular, they're at right angles, and that means the dot product of them is equal to 0. Okay, so this is question 1. So when I perform the dot product of these two vectors, it's going to equal 0. So I have 2 times 3, I'll run it out, plus 1 times 0, plus t times 3, that's going to equal 0. So we're left with 6 plus 3t is 0, gives us t is minus 2. T. Okay, on to the second one. Here we have the modulus of A is 3 and the modulus of B is 5. And we're told to determine what can we know about the dot product of A and B. Okay, so for part A, it doesn't matter what the modulus is, the dot product of A and B, if they're perpendicular, will always be 0. Okay, on to question B. What can we know about A dot B if A and B are parallel? Here we're going to use the second property, which has the modulus of A dot B is equal to the modulus of A times the modulus of B. So we're interested in what's the value, what's the question asking? It's saying what's the value of A dot B? Well, we know the modulus of A and the modulus of B, that's 3 and then multiplied by 5. So we have the modulus of A dot B is 15, which means the dot product of A and B could be positive or negative 15. Okay, so we've answered the question successfully. All right, part C says, what about if they're at 45 degrees to one another? Now, all of these flow from what we were doing last lesson, which was calculating the angle between two vectors, which follows this formula. All right, and we're just going to chuck in what we know. We know the angle is 45. When we want to know the dot product, and we know the modulus of A times the modulus of B is 15, we'll multiply both sides by 15, and we'll get 15 cos 45 is equal to A dot B. And we can evaluate that. Cos 45 is root 2 on 2, so we've got here 15 root 2 on 2. Excellent. And then on to D. What can be determined about vectors A and B if A dot B is equal to negative 2? So here we'll draw you to the third dot point. We've got if theta is acute, then cos of theta is positive. If theta is obtuse, then cos of theta, then the dot product is going to be negative. And so what we have is theta is an obtuse angle. So to answer part B, what can we determine about vectors A and B if A dot B is equal to minus 2? The angle between vectors A and B is obtuse. Very good. Good. Okay, now we've got this three-dimensional box problem, and you'd probably be able to solve this without using vectors, right? But I think it'd be a bit of a long process. So we've got a number of points on it, right? We've got O, we've got P, L, M, Y. We've just put lots of points on it. I think that's all we need to list. Given point Y is located 4 units to the right, 2 units up, and then 5 units back from O. So what that means is this distance here is 4 units, this distance here is 5 units, and this distance here is 2 units. So let's answer it in terms of vectors. So we can declare point O as the origin, the point of origin, right? 0, 0, 0. Now, point P, all we've done to transform to point P is gone across 2 units. So the coordinates of P are going to be 2, 0, 0. And for L, we've gone across 4 units, 4, 0, 0. We haven't gone up or down, and we haven't gone in or out of the page. Now, we're particularly interested in angle PYL, which means I just want the coordinates of P, Y, and L. I'm not going to worry about N and so forth. So Y, to get to Y, we've gone across 4, up 2, and back 5. So we can put minus 5 there. We're going back 5 units. Very good. Okay, so we want to know what's the angle between P, Y, and L. So it's a 3-dimensional angle. We're figuring out what's this angle in here between vectors YP and vector YL. So all we're going to do is find vector YP, find vector YL, and then find the angles between them. Vector YP is just the vector, the coordinates of P take the coordinates of Y. So that's going to give us minus 2, and positive 5. And vector YL is going to be the coordinates of L take the coordinates of Y. 0, minus 2, positive 5. Okay, so then in order to find the angle, we'll use the angle formula, which is Alright, so we want the modulus and the dot product of both of them. And I'll just put it straight into the formula, I think. So I have positive theta is, now if we do the dot product, we'll take 0, plus 4, plus 25. Then if we do the modulus, the first vector will be 4 plus 4 plus 25. So that's going to be 33. The second vector will be 4 plus 25, 29. Inverse cos. .3556 radians. So stake the 4 figures, round the 4th. All right. Clear the board so we can move on to the 4th question. So this is an old exam question. And I keep throwing these into the notes every now and then. So we've got vector A, which is 1, 4, now I'm not sure why they put commas in there, 1, 4, minus 1, that might be my fault when I printed the video. B, minus 1, 2, minus 2. Okay, so we have these two vectors, part A. Find the modulus of B. Alright, so the modulus of vector B is just going to be the square root of 1 squared plus 2 squared plus 2 squared. Square root of 9 has to be 3. Has to be positive because modulus is length. We want to know how far is it for the extent of the vector. So the modulus of vector B is 3. Show clearly that the angle between A and B, as shown in figure 3, is pi on 4. So find the angle between vectors A and B. So we'll just write it out. It's the dot product of A and B, so at the top we're going to have minus 1 plus 8 and then plus 2. Alright, so I'm just doing the dot product in my head. 1 times minus 1, 4 times 2, minus 1 times minus 2, adding those components together. And then at the bottom we'll have the modulus. The modulus of A will be the square root of 1 plus 1 plus 16. That's going to be 18. And this one we know is 3. Okay, let's just simplify that a little bit. So we'll have, at the top we'll have 9 on top of 3 root 18. Alright, and now if we do inverse cos, we can see that angle is 45 degrees or pi on 2. So what they're looking for is the demonstrating and understanding of application of the formula. However, maybe I'll just show you one more link that we can make, and that is to make this the same as 1 on root 2, or root 2 on 2. And the significance of that is that we'll have the inverse cos of 1 on root 2 is obviously 45 degrees because that appears on our unit circle. So the way we would do that is we can express root 18 as 9 times 2. Okay? So then we can split it. Root 9 times root 2. Square root of 9 is 3. So we're left with 3 times 3, which is 9. We have 9 at the top, 9 at the bottom. We'll cancel. We're left with 1 on root 2. Okay, so surd applications can take us to there, but inverse cos of that would be 45 degrees. Okay, so that's part A, part B. Part C, given point A, so we've got this point A, which has coordinates 3, -4, and +2. Okay, given point A, find 2 points M and N such that the angle between them is pi on 4. So this is point A, we've got 2 points M and N such that the angle between them is pi on 4. Alright, we need to find these points. So let's just call them for now. M can be X, Y, Z. N can be B, Q, R. And what we know, okay, so we should use what we've done previously. Alright, we know the vector, the angle between vectors A and B is pi on 4. So that means if I make AM equal to vector A, and AN equal to vector B, then the angle between them is going to be pi on 4. So that's all we're doing. We're going to say vector AM equals vector A. So we'll just solve this one first. Maybe I'll list them both and we'll just do them side by side. And vector AN equals vector B. So vector AM, the vector from A to M, is equal to X take 3, Y plus 4, and Z take 2. And I might just move to my left. I'll put the vector A on my left. Is equal to 1, 4, minus 1. Alright, so X take 3 equals 1. X has to be 4. We've got Y plus 4 equals 4, so Y is 0. Z take 2 equals minus 1, so we've got Z equals 1. So our vector then is 4, 0, 1. Sorry, that's not our vector, that's our coordinates. Coordinates of M, 4, 0, 1. So, because what are we asked to do? Find coordinates M and coordinates N such that they are at 45 degrees. So that's coordinates M. Let's do the same for N. So we've got vector AN is going to be, I'll write a bit smaller, P take 3, Q plus 4, and Z take 2. Same vector, and it's equal to 1, minus 1, 2, minus 1, 2, minus 2. Alright, so P take 3 is minus 1. So we'll have P is positive 2. Q plus 4 is 2, so Q is minus 2. And Z take 2 is minus 2, so Z is 0. So the coordinates of N then are 2, minus 2, 0. Okay, now there are multiple coordinates that will satisfy this because we're not involving modulus in any manner. We're only interested in the angle between them. So that's what we've put there is suitable, and we've applied what we've done. Now, does that make sense? Okay, really good. Now, part E is a really good example of a place where we do not want you to get stuck. So, because part E here says, state 2 vectors, neither of which is parallel to any of A, B, C, D, and that are at an angle of pi on 4 to each other. So we want two new vectors that are at 45 degrees to each other that aren't necessarily parallel to either of these. So I think the best way to think about this is just, because here you could spend a really long time trying to get 2 marks. Okay? But I think the fastest way to think about it is just to go to your unit circle and go, if I want 45 degrees, okay, what that means is we would have gone across 1, 0, 0, and then up here we would have gone, we could have 1, 1, and 0. Now, if I've done that, right, what's going on between these two? If I've gone across 1, and then if I've gone across 1 and up 1, then this angle has to be 45 degrees because we have an isosceles triangle. So, we're asked for 2 vectors. So, vector 1 and vector 2. And obviously there's an infinite number of solutions that can satisfy this. But yeah, that's probably the best way to think of it. And it's one where you could get stuck. We don't want you to get stuck. Okay, something like this I think is worth 2 marks. So at max you should be spending on it 2 minutes, and if you haven't solved it by then, ship on. All right. They're tricky marks to get those 2 without that sort of insight into triangles. And when I explain it, I mean it's very obvious and it's very easy, but to make that connection can be quite challenging. So there's a lot of questions in 7G2. I don't think we'll find them overly challenging, but we'll just rip in. And our plan for this week isn't a whole lot, because vector proofs, there's a fair bit of questions in there when we get to them as well. So